Next we have Venkatram Aurva from Syntiant Corp. He'll be talking about IoT evaluation in smart homes, focusing on various IoT technology and standards in this space and how the security, safety, reliability, especially in IoT home automation and especially where the voice, what role that the voice plays inside your home IoT devices. Personally, more about him, that he's the head of the R&D team there. He has a 24 plus years experience in this IoT space, so we are glad to have him. He's currently focused on how to do machine learning, always on machine learning on battery powered devices, which is a little different from the machine learning that we see in the cloud space and other space. So it will be very nice to hear from him. Let me set it up.
Thanks, Dhruv, for the introduction.
Everyone please join. We are starting.
Hi, good morning, everyone. My name is Venkatram. I represent Syntiant Corporation. I am the head of the India R&D Center. We just started this center a couple of months back. We are headquartered in California. It's a startup, around 50 people with 50% PhDs. Average experience is 20 years. Okay. So, primarily, about myself, I've been in the communication, embedded, mobile, IoT for about 24 years. I worked in different companies like CDOT, Motorola, Samsung, Sasken, Smarthome, and now Syntiant. So primarily I've been focusing on IoT and commercialization of IETF protocols, RFCs. I wrote first kind of DNS client in 1999 for mobile. I integrated wireless profile TCP in 2002 on a mobile platform. Imagine the constraints what we used to have those days, the memory, processing limitations and everything else. And I did work on HTTP stack integration. First IPv6 commercialization on a mobile platform, first in the world for Metro PCS. This is for LTE deployment. And second in the world, mobile device with IPv6 for Verizon Wireless from Samsung again. So I've seen the evolution of it, but interestingly, I kind of implemented RFCs, but I never part of IETF conferences. Thanks to Praneeth and Dhruv and team, they kind of connected me. Praneeth used to work with me, so thanks to her. Nice connecting with all of you folks. So today's talk is focusing on IoT briefly. What is IoT is all about, how smart home is evolving. That's where I did a lot of work last 2-3 years commercializing products. And then how voice is changing the game. Okay, so I just talked about the agenda already, so we'll just jump into this one. So what is IoT is all about? It's mostly about how you integrate constrained devices. Low power, it could be battery powered sensors, actuators, low memory, low processing capabilities. So all of these devices, mobiles used to be like that like 20 years back. So we did some work. So same work is happening now to bring those devices in, connect to internet, because many of the users want to know what's happening with those devices, and they access the data, they get inferences, analytics via cloud. Okay. So other thing is managing the communication and managing the devices, because devices have to be always on most of the time if you want to handle certain security at home, or it could be industrial IoT, it could be anything. So other thing is interoperability. So primarily what it means is that there are a lot of protocols. I will talk about it specific to smart home, but there are a lot of other areas as well. So they have to interwork. So standardization would help us with interoperability. During commercialization, I found a lot of challenges making it work. So the other thing is seamless connectivity and services. So even I'm outside home or wherever I am, I should get what's happening at my home for smart home, right? So if you see all these proprietary protocols, sometimes which are kind of proliferated in the IoT space. So when it comes to internet, again they go through the standard protocols like TCP/IP and the HTTP. So I'll talk about a little bit of like some customization which are done for handling IoT. So if you see, because these are constrained devices, they kind of send data and go to sleep sometimes, battery powered devices or any of the IoT devices, actuators, and they won't have always on connectivity. So internet has to change the way it communicates or gather the data about the sensors and feed the inferences to user via cloud. So that's where there's evolution of like MQTT, Co-op, which is again like kind of similar to HTTP, but which is based on like lightweight implementation. So these things will change the game. Again, IPv6 is widely used in the IoT world because the proliferation of devices, there are more and more devices are going to be in the house. So earlier, having one mobile at home or phone itself was a big deal. Now I have like 40 devices at my home, including all IoT devices. So you need to have IP address assignments, managing the network, etc. So security is the biggest thing. Okay. So if you see the ecosystem or layered model, I'll just point a little bit. So IoT caters to different markets, like it could be like smart industries, industry 4.0 kind of stuff, connected home. So wherever you are at, like let's say I can see how many lights are turned on at my home, what's the power consumption. Any security breach happened at my home right now, I'll show it on my mobile after this maybe. So other thing is connected cars, like basically you can turn on, turn off. Before you get into the vehicle itself, you want to know what's happening with your vehicle. Somebody is like tampering with your vehicle. So all of that is like kind of different segments like smart health, smart infra. So this is all to help, like optimize the power consumption or kind of give better experience to the user and leverage the all the sensor data which is coming in. So basically, all this data is we're going to acquire based on sensors, cameras, or it could be any of the meters, smart meters, and they kind of support different IoT protocols. Okay, and some data might come from smartphones, wearables, and other stuff as well. So how does the interconnection happen? That's the next layer. So these are all the standards: Zigbee, Z-Wave, mostly for smart home, and 6LoWPAN again it's a low power WAN. LoRa is like a little bit wide area for smart cities kind of segment. So again, Wi-Fi is evolving. There's a Wi-Fi mesh. I'll talk about it a little bit. What's happening in that space? BT, BLE, it's evolving. Like 5.0 standard is evolving. But I see widely, Zigbee, Z-Wave, Wi-Fi mesh, Bluetooth is used. Is not that popular in the smart home segment right now. But most of people are using it as a smart speaker, like a source and sync ADR-CP profiles. So the data integration is done, kind of like, to derive certain inferences. And basically, the next layer is kind of doing the predictive analytics. So because user doesn't want to know everything what's happening at sensor. He's interested in, let's say somebody kind of broke his main door or somebody entered while he's not there at home. So he just wanted to only that. And we need to minimize the interactions for user, and he can subscribe. So all of that can come through machine learning, predictive analytics, and data mining and AI. So I'll talk about a little bit on how that is moving to edge. So our company, Syntiant, works in that space with some of the biggies in the industry. So next thing is, these are all applications, like transportation, industry 4.0, health, infra, education, and agriculture. So security and the management of these devices is very important because a lot of small players are going and implementing like customizations, not looking at the standards. So that creates a lot of challenges, and many of the end user doesn't know what is in that device, what is there in that gateway, what kind of security implementations are provided when I'm accessing the data. So that's a little bit challenging. So how many people have smart home deployed? Okay, so yeah, only a few. Okay, I can also raise my hand. I just deployed it at my home. So what is smart home is all about? Okay, so it's primarily, kind of making your home smart in terms of providing safety and security and basically energy management. So you want to reduce the cost of your electricity and water utilization and all that. Other thing is water management, and like it's becoming more important to conserve water, and who is using more water. Sometimes every house has connection and everybody uses whatever they want, but if you have a smart meter, we can alert where the water is getting wasted in real time. Other thing is, in the smart home space, there's a lot of voice controls which are evolving because of Alexa, Google, bringing in their voice solutions. I'll touch upon that topic in detail later. So again, basically the scenes and routines, you automate controls. Let's say my outdoor lights, I don't need to turn on in the evening. So based on the time, based on when it is getting dark, based on the sensor data, based on the lux information, if light is not there, it should turn on so that energy is efficient. And it should go out by 9 p.m. roughly. So you can automate something like that. And you can say, okay, party time. So then, using voice commands, and you can automate entire controls, projector turns on, AC, and all the lights will dim, that kind of stuff. It's convenience. So safety, security is the most important thing, and next is energy management. These are the top two things. And these other things are like convenience and like luxury for users. So all this sensor data, which is embedded into different devices, is kind of gathered and provide, inferences to user via cloud. So when he's at home, he connects through like some kind of Wi-Fi router. Otherwise, when he's outside, he goes through cloud. So basically, all these are appliances. So a lot of appliance vendors are embedding different technologies, and some of them are Zigbee, Zwave, Wi-Fi, different technologies. I'll talk a little bit more in detail. So basically, giving unified experience to user and also security and what user wants. There are a lot of discrete device makers, so we need to standardize the way users use and give a better experience. So, okay, so these are some of the things which I mentioned. So Zigbee is one of the popular ones. Z-Wave, Wi-Fi mesh, voice for IoT. So Zigbee. So there's an alliance for Zigbee and primarily voice. Especially Amazon is mostly kind of supporting Zigbee. Z-Wave also they support, but mostly it is Zigbee as a popular, including their hubs, voice gateways, right? Like for example, Echo Plus, etc. So a lot of companies are leveraging Zigbee as a standard. So what is Zigbee is all about? So it's driven by a Zigbee alliance, okay? So it's built on top of the standard 802.11.4, okay? And it supports multiple hubs. What it means, so you have like multiple sensors, actuators. So if the device is a little far from the gateway, so you can still reach the gateway through the intermediary node. I'll talk about that in the next slide. So that is achieved through different mesh topologies. So they're like star, mesh, and the other combination of that. So the mesh is the one which is popular. So I have next slide which talks about that a little bit. So why do we need mesh? So sometimes my outdoor light may be far away from my gateway, Zigbee gateway or Z-Wave gateway. So I need to go through a power device which acts as an intermediate router. So to reach, let's say I have to reach Calcutta. If there's no direct flight, I have to go through like maybe an intermediary like Delhi, come to Delhi, maybe come to Calcutta, something like that, nearest airport. That's how it is. It's a real-time example. So theoretically it supports 65K nodes, but practically you don't see it working that way. So basically, if you have like 30, 40 devices, I think the performance kind of degrades. You see latency sometimes, intermediate node goes down, so it has to rearrange the mesh. So other thing is it operates in 2.4 gigahertz, which is ISM band. That's where even Wi-Fi is operating. So we have a lot of challenges if you have to use Z-Wave along with Wi-Fi with the legacy routers, which are only 2.4. If you use mesh router, what happens is there a lot of noise in 2.4 because like Bluetooth is communicating, Wi-Fi is communicating, a lot of devices at home. And Zigbee is also communicating. So you see like some kind of interference. So you see latency. So for that you need RF coexistence. That complicates things again. And then hardware costs go up, or for user it doesn't matter, but as a technologist it matters. Okay. So other thing is, so they are planning to come up with a new standard which works in other sub-gigahertz. Also 2.4 range is less compared to sub-gigahertz. So I'll talk about a little bit the Zwave on that aspect. So devices cost is low for Zigbee compared to other technologies. The reason is certification is not must. So people can just adapt whatever HA profile 1.2 or any other profiles and then deploy. So certification is not mandatory, that's what I said. That's why everybody is trying to make their own devices. They don't test sometimes thoroughly. Certification is for interoperability. So when you make a device, for example, one device maker like Honeywell's device will work with Amazon's hub versus Samsung's hub. So that kind of stuff. So Zigbee 3.0 is a new standard which will solve some of those problems. Okay, so they're learning from other proprietary standards, including Zwave. So what is mesh? Mesh is all about you have the main gateway, and the gateway is talking to the cloud, and then provide connectivity for user experience. And there's a Zigbee's coordinator is called this is called gateway, and then there's the intermediate nodes which are power nodes. These are like router nodes. So they extend network to the end nodes, which are sensors. Sensors are battery operated. Basically, they kind of send the data whenever certain event happens and they go to sleep. And then again, they wake up whenever certain event happens or based on some timer triggers. So they can't be awake all the time. So they're called sensor devices, battery operated. And the middle devices, which are kind of acting as routers, are actuators. For example, they are power devices. And they have the actual power, wall plug. So limitations of Zigbee. So primarily certification is not mandatory with the current standard. So 3.0 is going to change that. So loosely controlled in terms of interoperability. That's why you don't have to spend money on certifying each and every sensor and end device. So basically that has to change going forward. So other thing is range is not comparable to Zwave or the other technologies because they operate in 2.4, which is congested at core. So other thing is security. Compared to Zwave, Zwave implements S2 compliance. You have to enter a key to onboard a device. So Zigbee is a little loosely, in terms of security compared to other competitive solutions. So interoperability we talked about because of certification is kind of not mandated, so that creates some challenges. So Zwave, what is Zwave is all about? This it's a proprietary standard. Basically, there's an alliance for it, and there are a lot of ecosystem which is very popular. So the devices are a little bit expensive, but because of certification, compliance, and other reasons, people trust Zwave a lot compared to Zigbee. So it's primarily, Sigma Designs developed this technology, so it's a proprietary one. So now Silicon Labs acquired Sigma Designs, so basically it's more under Silicon Labs, but it's still Alliance. There's an Alliance which controls all certification, specification, and everything else. Again, it supports hops, still 4 hops, but practically you see 2 hops working well in a home environment. So you can have maximum of 232 devices in a mesh network. So as the device, more and more devices are there in the network, the performance may degrade. Practically 64 kind of stuff is much better, like 40 to 60. So mandatory to get Alliance certification, without which you don't even get a chip to ship along with your device, because you need to manufacture. There is a certification code which gets imprinted into the chip. So the cost is high, but compliance is good. And if it works, means it works. So that's the advantage of Zwave. So it operates in sub-gigahertz. What is sub-gigahertz? It's basically the range is more. One disadvantage is there because of it's different frequency bands are used across different countries. So you need different certifications in different countries. So again, the range is better. and there's no interference because it's not operating 2.4. Okay. So, what is the time? Yeah. Security, S2 is a must, and this is like kind of very stringent. This is a new standard for security because you may have a lock at home which you don't want it to be tampered, right? Smart lock, which you might open from. If you have a visitor, you can open from your office or anywhere outside. So better range than Zigbee again. So there are a lot of manufacturers. It's widely used. There are a lot of devices which are certified. Without certification, you cannot ship. You can have only 500 samples for kind of piloting. Beyond that, you cannot. So the advantages are like mostly plug and play. It's mostly you can do a lot of things with the app or like this thing. Once you set it up, things are fine. So better range than Zigbee. So I talked about S2 security, good ecosystem of manufacturers. So limitations. It's a proprietary standard. So frequency is is a region specific. Let's say India versus Europe versus US, the frequencies are different. That means you can't use devices which are working there, bring it and use it here. So you can have up to max 40 to 50 nodes, okay? And that's in reality, like though they claim 230 plus devices, in theory. So certification cycle times are long generally. Because each device you have to certify. If you change you add a new feature, you have to recertify. So it costs money. So devices are expensive. But performance will be generally better because it's tightly controlled. Okay, next. So these are all type of devices which are used in smart home. So smart locks, thermostats, sensors, sirens, smoke detectors, and all that. Some of them are battery operated. So window curtain controllers and like smart plugs. So you can convert. There are retrofits as well, which goes behind the switchboard. The existing switchboard you can convert into a smart switch. So I do that at my home because so you can even add voice to it. So the legacy switch has a module behind it, so it can take voice, it can take any other command. So only thing is it doesn't look fancy, but it becomes smart. So what is Wi-Fi mesh? So this is a traditional network of Wi-Fi. So you have a router, all devices are connected in like kind of star topology. So if you have one device which is far from the router, you don't get coverage. So that's a problem. So star topology is spotty coverage at home. You have in India we have like brick walls. So these cannot penetrate, signals cannot penetrate. So no seamless handovers sometimes. I have two routers to extend coverage, then it has to disconnect and reconnect sometimes. Depending on the type of router again, technology. High cost because you have to deploy more and more devices for better coverage and because of all these limitations, bandwidth issues. So what is Wi-Fi mesh is all about? Again, it's similar to Zigbee Z-Wave, the same similar thing. You can extend one. There's something called, basically the devices. You have like for example mesh gateway. You can have another repeater kind of stuff which is connected, and then you can have another repeater like two hops, theoretically or practically, and then extend the range. And if one router goes down or you move from here to here, all these gateways are kind of within the same IP address range. So you get seamless connectivity because of streaming and a lot of other use cases require mesh nowadays. So this is a next gen standard. So it's a self-configuration. You just take two devices which are mesh capable and just press WPS button, it clones the credentials. You don't have to do much. It's very easy to set up. That's how the technology is evolving. And it manages switching between 2.4 to 5 gigahertz because if you're far off, you have to use 2.4. If you're close, 5 gigahertz gives better speed, but range is low. So it auto-manages. And depending on how many, if 5 gigahertz become congested, it will move the devices to 2.4. That's called AP, like kind of, the band steering. Another thing is, if one AP, like we are moving away from one AP to other AP, like kind of, it steers automatically and traffic gets rerouted. So self-healing, let's say any node goes down, it kind of like reconnects, recreates a mesh. Again, security, right? As long as you are within this gateway, the main gateway, which is connected to backbone, so you're all secure, even though you have multiple repeaters. Okay? Yeah. Other thing is next. It leverages next-gen standard. It uses a tri-band, between these two central access point and repeater. Also 802.11 AC, which is kind of better standard than the legacy BGM. So multiple hops for better coverage. So again, some device makers are making proprietary extensions, like Qualcomm makes SOM, self-organized network, and other chipset vendor makes something else. So that doesn't work with one vendor and other vendor. That's a constraint. Let's say I buy Netgear and RB versus I buy Google Mesh routers. They don't interwork. So you have to buy only Google Mesh routers, and you have to buy pay at some time. So you already have something. You want to buy another better one, cheaper one in the market. Then again, it's a constraint. So again, cost is high, but I think cost is coming down slowly. So interop across device vendors is a constraint. So what it gives is, for smart home, you need a better coverage because nowadays you have a 40, 50 devices at home. So what is voice? How is voice changing the game in the IoT space? So you can control, the devices, smart devices with voice. So you can have like scenes. You can say like party time, movie time, or like I'm leaving home. It will do everything for you. So you can make calls between the devices. And controlling vehicle functions with voice. So that's what is coming. It's already there in US and other markets, Germany. So it's going to come in India as well. We do right now with other Android autoplay and Google Auto, like Android Auto plus other things. But it's going to be built in going forward with all voice interactions. So security camera, you can say, show me the front feed of my house. It will show that, just with voice. So how the voice is enabled is based on the smart home skill. What is Amazon is enabling for device vendors. So you make a kind of this is the Alexa service, smart home skill API, and basically you have to develop some functions to connect your hub to the Alexa skill. So through cloud. So basically you can issue commands and it will kind of send directives to trigger certain things. So you can do scenes, automated routines, independent of IoT gateway. So irrespective of what technology you're using, as long as you cover things here on the cloud side, you build a smart home skill, you can enable voice for your devices. So basically, I talked a little bit about AI machine learning. So Syntiant is doing some work in this space. Basically, we move kind of machine learning from cloud to edge for low power, ultra low power devices. So what it means is basically battery power devices like hearables, wearables, or you have like any device which is like very, very low power, like hard patches, anything. You want to add voice to it. You want to run machine learning algorithms on the edge because battery power is very, very important there. So what we do in-memory computing with high accuracy for ultra low power devices. So primarily the chip can do like the 20 wake word recognitions offline. You don't have to connect to cloud. Currently what Amazon, Google, everybody does is they do recognition on the cloud as well. Okay, so we build the AI for smallest device like earbuds, wearables, and all that. So and kind of basically we are replacing all the touch interactions. So voice is going to be the next big thing in the next 10 years. Human interactions, the voice interactions are the natural thing for human beings. Touch is not natural. Okay, so the way we are interacting with devices is going to change in the next couple of years. And basically we target mostly battery operated devices. So current challenges, mostly people are concerned about privacy and security. So sometimes what kind of questions I'm asking, how many times I turn on my light, what kind of stuff I'm asking. So some of the celebrities, they want offline voice. They don't want to go to the cloud. Sometimes whatever they spoke, it gets into Amazon cloud, Alexa cloud, someone looks at it, posts it somewhere, it's a challenge. So language support, it's evolving. Right now Hindi has been launched recently in India. So this is another thing. Smart home skill support is limited, depending on limited number of devices. So again, basically enabling voice for low power device is a critical thing, right? Because you can be driving or you can be like, say Alexa call from your earbud. So reducing the cost of devices which support the voice. So summary, right? Primarily the IoT smart home standards, they don't interop, and cost of devices have to come down for adoption. I see only 3 people have adopted so far. Only 3 people have raised their hands. So I think hands-free capabilities, basically will make the smart home and experience better across segments. And seamless connectivity services, using the emerging standard, I think IETF is doing a lot of work. So it's important to bring everything together, make sure it works, interops. Security is still a concern. So what we see, most of the users don't configure their routers at home properly. So everything is open for many people to hack it. So though router has a capability, we don't configure it right. That's why smart home becomes vulnerable. So that's all I have for today. Any questions?
Quick question.
So I have one demo of 30 seconds video. So maybe once questions are done, I can
Quick question.
Yeah, Venkatram, what do you see the future of 5G in smart home?
Yeah. So basically, 5G is yet to come. But what we see is narrowband IoT is being deployed by most of the guys in the IoT space in the next 1 year, in India at least. So IoT is going to change the game, but for the wide area network the communication. So what we are using is what I talked about is a low smart home, which is limited to home or automotive or industrials, which is very very limited area. But 5G is going to bring adaptation for IoT, which covers a larger segment.
I have a couple of how do I say contextual or overarching questions. One, I know that a lot of people have concerns. This thing is sitting here listening to everything I'm saying, and then next thing I know, it goes to the FBI. I'm serious. A lot of people have a lot of concerns about that. And the next thing is we have IoT for smart homes. Where is IoT for smart village? Because again, this is, I feel like really, don't get me wrong, I love technology too.
Yeah.
But I feel like the divide, you're talking about future which we don't even have. And then so many people are left behind. Yeah, I don't know.
Yeah, so especially in villages nowadays, there are people are making small devices which you can turn off motor. Most of the villagers, the farmers don't have a method to they have to be awake in the night to turn off their motors. So some of these are evolving. I see, whatever has been happening, they are mostly SMS based or GPRS, some SMS, some low power technologies again, and low cost is very important to deploy. So,
Yeah, just carrying forward from her. The connected universe ecosystem, we see a lot of devices, and a lot of devices means a lot of energy consumption. So how is IoT going to mitigate that challenge? Along with, say for example, when IoT will be commercially deployed at every household, so most of the government, the pastel factors, most of the government will send forward, these are the list of protocols that we are allowing. So if I move, say for example, if I go from India to Australia today, I have to buy an international PIN. So will there be some sort of enabler to take my entire smart connected ecosystem when I go from one country to another in future?
yeah, that's interop is a challenge. Again, to answer your question of power consumption when we have too many devices, IoT helps you reduce your power consumption. That is one of the values. Because it will turn on only when it has to turn on. Sometimes I turn on the light even though I want to go out, so I will turn on my outdoor light and go out. So it's based on like what's happening surrounding, based on the light intensity, based on the temperature, it will turn on the air conditioning. So it will optimize the power consumption. That's the main value of smart home and IoT. Yeah. So and other question is, okay, so interop between different countries is still a challenge. It's a standardization issue. That's where I think this kind of forums, being part of IETF and standardization will help to bring even like the Zigbee 3.0 is trying to adapt and interwork with other technologies. So that's coming actually.
Sir, I'm curious about the current state of progress in the security in the field of this IoT. Like most of the standards are proprietary, as I saw in the slides, and what is the those are the open standards are not there. Mostly those are proprietary. So, like, what is the state of current security? Like, what is the standards are there? What are the security measures, and what implication can a quantum computer can have on the security aspect of the IoT?
Yeah. So security again in IoT, we use all standard security, like AES 128, it uses like TLS, whenever we establish connections with the internet, and even within the network, home network, it uses standard security compliance, security standards. Only thing is, how do you configure it? How do you leverage it? And between Zigbee, Zwave are driven by two different powerful guys. They want their thing to be in the forefront. Right, so two companies proposing some changes to RFP, they compete with each other. It's a similar thing, but at some point it will converge. But security, to answer your question, they use all standard stuff.
Thank you.
Yeah. Thank you.